Even, odd functions. A function is even if for each x in the domain, okay? If that's true, you're dealing with an even function. And it's symmetric with respect to the y-axis. I always remembered, I don't remember what grade I was in, it's just, we painted a butterfly, and to do that, you have the picture of the butterfly there, you folded your paper in half, right, get the line down, but you only painted half of the butterfly, and then you smushed it together, and then you open it back up, and you had your butterfly.
Well, yeah.
That's probably, 11th grade, 12th grade. I was an advanced student. So the y-axis. So even functions are like the butterfly because on the y-axis you can fold the paper in half and the graph looks the same. Okay. What this is telling you is that if I plug in an input and you do the opposite input, we get the same output. So in other words, we move to different spots in the x-axis, but we're at the identical height, whether it's positive 10 or negative 10. A function is odd if this is true. And how I refer to that is, one person does a negative input, one person does the opposite of the function, and if you get the same output, then you have an odd function. This is what they call symmetric with respect to the origin. And I describe it as two folds. You would fold on one axis first, and then you fold on the other axis. So in other words, you might fold everything down. So the top half of the graph comes down, and then you fold it on the y-axis after that, and if it's the same. So really, you'd have to have something in the first quadrant that would line up with something down in the third. Can you visualize that? Twofold. So the first quadrant maybe goes down first, and then it comes over into the third. You'll see it on the graph. I really don't like working with the absolute value stuff, so we're going to switch out that function, and let's make it so we're not switching it a whole bunch, but when you're doing an odd or even function, yes, you can get lucky, and if you start a certain way, maybe you'll find it faster. I would always get in a habit of doing the negative input first. Because if you look at the rules that we just had, you're going to compare the regular input versus the negative input to see if it's even. So let's just do that first. So put a negative in, what do you get? Negative x goes in, and I raise it to the fourth power. Negative x goes in, and I raise it to the second power. Now notice my location of the parentheses. We're taking x to a power, so you want to make sure you get that x in parentheses. What is negative x times negative x times negative x times negative x? X to the fourth. If you lined up 4 negative signs, it's going to be positive. What's negative x squared? So what's negative x times negative x? Positive x. Now we're subtracting it. So this is what you end up with. Is the original function the same as my output right now? Yes. Yeah, these are the same, right? F of x equals f of negative x. So when those two things are the same, you have an even function. What does this graph look like? X raised to the fourth minus x squared Would you fold it like a butterfly and it'll be the same? Yes. I'm just zooming in a bunch. You can kind of see. I guess I wasn't zooming in maybe. You can kind of see how there's a little bit of a W shape there, right? But anyway, it's got the basic U shape to it. But the idea would be you can fold on the y-axis and you'd come out with a butterfly. Even function. Now the whole folding idea is not mathematically correct to say this is an even function. You use the picture to kind of give you an idea of yes it is or no it is not able to fold. That gives you an idea of what you're doing. All right. X over x squared plus 1. So I'm going to start by doing the negative input again. So the negative is going up there, and it goes down here, wherever I see an x. So this is negative x over negative x times negative x is positive x squared plus 1. Is my original function and the output where I did the negative x, are those two the same? No. The denominators are the same, but the top, one's positive, one's negative. So this is not the same. Okay? So that tells us we have to try something else. So we're going to do what's called the negative of the function. So I write out my function and put the negative out front. Now we have to talk about when you take a negative to a fraction, does the negative sign go on top? Does it go on the bottom? Or does it go to both the top and the bottom? It does not go to both, because if you take a negative sign and put it on the top and the bottom, you end up with a negative over negative, which keeps it positive, so you didn't change it at all. So not to both. We tend to put it in the top rather than the bottom. You can put it in either spot, but only one of them. So what I'm going to do is just bring it up to the top. Now when you compare this output, you compare it right here to the output where you did the negative x. So if you just do this in order, the first two you compare their outputs, and the second two you compare their outputs, and that's why I like you to do it in this order. Is this green output the same as this blue output? Yes. So they're odd. Right? So I have x being divided by parentheses x squared. Was it plus 1? X squared plus 1. Zoom. Go back to a standard window. You can't really see what's happening, but I'm not going to zoom in on it. It's kind of following down along here, and it comes down a little bit, and it goes back up, and then So if I fold this graph like a butterfly, what's going to happen? You could say that like the top part would be over there, right? Okay, so that tells me that it's not an even function. But now I've already folded on the vertical. Now if I fold on the horizontal line, that dotted line would drop below it. Would it land on this graph? Yes. So visually, hopefully you can see that what I was talking about, something in the first quadrant, you fold it either on the vertical or the horizontal, and it will end up in the third quadrant. If that matches up, then it's odd. H of negative x goes in. Are these two things the same? No. So we're not talking about an even function. We do the opposite of our function, so I put a negative in front of x plus 6, and that turns out to be negative x minus 6. Are these two things the same? Close, right? I mean, we have they're going to be parallel to each other, but we have plus 6 up there and negative 6, so these are not the same either. So this is not odd, this is not even, it's neither. If you graph the original, again, if you fold it on the y-axis, you would not end up with a butterfly. If you fold it on the y-axis, the thing that's over here would end up right here. And then now if you fold on this line, it would end up about right there. So it doesn't hit. So we're not folding twice either. Is that it?